if you guys are not familiar with CentralLogic, we're a global digital IT transformation company based in Toronto. And we really specialize in helping guide our clients through the process of getting through a digital modernization effort. May that be across cloud, data, and infrastructure, and really kind of transforming applications. That's where our collective of solution architects, engineers, and data scientists really kind of like help out. And so we organize our services in our company into kind of like four major categories. One's around application development, so really doing pure code development, doing pipelines, automation in terms of delivery. We also have a cloud and infrastructure team around focusing on migrating to cloud, developing underlying infrastructure, driving infrastructure as code, and kind of figuring out how to deploy that across multiple cloud providers. We have a strong data and AI practice, and you'll hear from one of our leaders, Dylan, today, and then cybersecurity. And that's kind of how we organize our company in terms of how we deliver. And why that might be important is if you have an organization that really has kind of an end-to-end capability around IT, it's really aligns really well, especially with the Databricks model. Because Databricks is cloud agnostic, and we want to make sure that we can kind of build flexibility and scale to really kind of like help drive usability and scalability across that. And so this webinar is really around kind of showing our proficiency in Databricks, but also from a capacity of understanding how it's links to digital transformation. So anyways, thanks for joining, and I'm going to hand this over to Dylan.
Great. Thanks, Imran. All right, so let's dive in here. So you can see from the title, I'm really emphasizing that Databricks allows you to unlock your data to make your AI projects smarter and more effective. That's really the core crux of the platform here. We'll get into that right away. So what are we going to talk about today? So I'm going to introduce myself. We'll talk about what Databricks is, because it's a pretty nondescript name. I think it deserves some clarification, and we'll dive into how that platform is composed. We'll take a look at architecture. So there's a lot of different flavors you can deploy. We will take a look at data management and data engineering. That's basically where Databricks has really been the highlight for me. We'll look at the DevOps ecosystem around Databricks. We will look at AI and machine learning, and I've got plus demo in there, but all these have demos, and then we'll do some Q&A. So really, it's a very demo-heavy presentation where I'm going to be really your tour guide for the Databricks platform, so you understand what capabilities come out of the box when you set up Databricks. Okay, let's start with who am I? My name is Dylan Berry. I have been a principal consultant, or I am a principal consultant in Databricks and for data and AI. I've been with CentralLogic since 2019. I have over 25 years of experience. It seems like a very long time as a technology professional. So I've done, you name it. So I've done web, data, mobile, DevOps, cloud, basically touched on almost all aspects you could in technology. In the last 5 years, I've really been focused on Azure Databricks specifically. I do have some experience over on the AWS side, but my core focus has been Azure Databricks. And I'm excited and passionate to help clients succeed with Databricks. We've seen working with our clients, we've seen some really, really good results working with the platform. And it's just I enjoy speaking about it and enjoy kind of praising it because it's one of the better technology products I've worked with through the years. So let's talk about what is Databricks. Like I said, pretty nondescript name. It's basically, they've marketed it as a data intelligence platform. Well, that's kind of more marketing knowledge. What does that really mean? It's a cloud agnostic, as Imran pointed out, code-centric data and AI platform. So it means you're not boxed in like you are with other potential platforms or frameworks where you're left with no code tools that have limitations and you can't work around those limitations. Being code centric is important to me. I come from a development background. I think a lot of people in tech come from a development background, are reasonably comfortable with working with code. So being able to drop down to code or use code to solve any problems you're presented to lends the platform to a lot of flexibility. So the core features that are part of Databricks, there's data engineering. So that's basically working with your data, right? So ingesting data, transforming data, making sure it's of high quality, that it's cataloged and tagged appropriately, getting it all prepared so you can do proper analytics on it. And then there's a huge set of features around AI and ML engineering. So Databricks is really, really strong. Once you have your data in the platform, you can do a whole bunch of work on it using AI and ML to really get the full benefit of the platform and of the data you've brought in. And there's a free edition. It used to be called Community Edition. I like the rebranding of it to Free Edition. It's a lot more straightforward. So you can start working with Databricks without having to really procure anything. You can just go and try it and get a feel for it just by going through the Free Edition onboarding. Okay, so at that, let's get into the first demo. So I want to walk you through the platform a little bit, and we'll talk about one of the core features, which is AI BI Genie, or one of the more exciting features to me. Okay, so when you land in Databricks, you get a nice welcome screen. It kind of just shows you some favorites. This is not really the meat. We're going to jump right into, I'll walk through each one of these menu items, and then we'll go through AI BI Genie. So workspace is going to be where you keep your files, basically. So this is storage, file storage for the workspace. Workspace is kind of like, you can think of this as an instance of Databricks. So this is where your files are going to live for the environment you're working in. So in here, you can do things like, create folders, attach it to Git. There's really good Git integration. You can create notebooks. Notebooks are basically like, if anyone has experience with Jupyter notebooks, it's effectively Jupyter notebooks. These come in kind of a few different flavors. I'll talk about that a little later. You can drop in a vanilla file, whether that's Python or data or whatever you need. You can create a query. This is essentially a SQL query. You can create a dashboard, and that's exactly what it sounds like. It's actually a reporting engine built into the product. Create a Genie space. We'll talk about that very soon. Alerts, that's data-driven alerts, and MLflow experiments, which are basically experiments for hooking up machine learning to your data. So this is the general workspace. This is where you deal with files. Recents, I'm going to skip over. This is just going to show you the things you've had open recently. You've got a catalog. This shows you your catalogs, any schemas you have underneath your catalogs, any tables within there. You can do things like mount volumes in here, which are pieces of storage. You have workflows. These are basically your scheduled tasks. We'll do a bit of a deep dive on that. You've got compute. This is your clusters that will be used to actually process your data. There is a concept of serverless compute in Databricks. I'll talk about that in a little more detail as well. And there's a marketplace. The marketplace is where you can go and get data sets. You can get different pre-trained models. You can get things that will help with ingesting data, transforming data. So you've got things like dbt and Fivetran, and there's Power BI integrations and all kinds of different things in here. On the SQL side, you've got a SQL editor, and this is exactly what it sounds like. It's a SQL editor. You can see it's opened up to a query, and I'm actually zoomed out too far. I'll take it down one notch, but it's a simple query engine. these queries are stored as files in your workspace. You've got your list of queries. You have dashboards. So those are the actual reporting components. You've got Genie. I'm going to come back to this in a second. You have your data-driven alerts, your query history, so you can actually audit what's being queried on within Databricks from where. Under data engineering, you've got it's a little bit repetitive here because workflows and job runs essentially take you to the same spot. Same with pipelines. Data ingestion, this is something that Databricks released about a year ago and has been really growing. So they've basically put in a set of features called Lakeflow. The data ingestion has been branded in the documentation as Lakeflow Connect. This is basically connectors, out of the box connectors here. So you can see you've got Salesforce, Workday, ServiceNow, Google Analytics, and there's more to come. You can do things like CDC ingestion, so change data capture events from SQL right in Databricks. There's native support from that. You can ingest from storage accounts, things like that. So there's a lot of power in the out-of-the-box platform, and then you've got things like they partnered with Fivetran. So if you're already using Fivetran, or if you have interest in Fivetran is a great way of bringing data in like kind of a low-code way. And then AI ML, you've got various ways of dealing with this. I'm not going to jump into this yet, but these are basically all your different AI and ML tools, which we'll follow up on in a bit. But the area I want to get to, and this is kind of the interesting thing from my perspective, is the AI BI Genie. So this is a feature that was added again, I think about a year ago. So Databricks every year holds a data and AI summit. Last year, or just before last year's summit, they launched this AI BI Genie product, and it's basically an LLM which is already pre-configured to with tools that will hook up to your data catalog. So what I've done here, and actually we'll just flip back here and look at the catalog. You may have seen this when I was flipping through. I've created a Formula One catalog. So I've ingested some data from an API or really a set of Python tools called FastF1. I've done some transformation on them, and then I built some AI BI Genie spaces on top of that data. So in AI BI Genie, we can now ask plain English questions about race results, which is really cool. So I'm going to use one of these canned ones because I've gone through the process of seeing what works, seeing what doesn't. Of course, you're using an LLM. It's non-deterministic, and giving it the exact data it needs to be able to intelligently bring back the data set you've actually asked for, and displaying the data in a certain way is kind of tricky. So I've spent a fair bit of time massaging the data and getting it to the point where we can ask a simple question. Show me the telemetry from Leclerc's fastest lap at the 2024 Montreal Grand Prix. So what it's going to do, it's going to look in our data. It knows where to go look. It's telling us this analysis presents the telemetry data, including speed from Charles Leclerc's fastest lap during the Canadian Grand Prix. It brings back a data set, and then hopefully it renders the graph as I expect. So it's collected the fastest lap, and now it is trying to output it. Of course, because it's a demo and I was playing with things earlier, it has not yielded the results I expect. Let me see. I think I can pull back the history here. Oh, maybe it's the zoom level. Nope. Oh, well, it's not rendering. But either way, you kind of see you get a good set of results. Part of the problem with working with the data I had is it was using interval types, so that's very hard for the LLM to interpret. But this is classic demo because I just had this working about a half hour ago. So good times there. But this is a really interesting way of looking at your data. When we're working with this data, you can now, once you've shaped your data, once you've gone through the data engineering process, like really shaped your data and made ensured that it's high quality, that you've attached the correct metadata to it, that columns are named appropriately. The model can actually look at that data, determine how it can query that data to get your results out in a plain with plain English language questions, right? So let's try another one. What is the maximum deceleration for each driver? Pretty open-ended question. This isn't going to give us a graph because I haven't asked it to graph anything. But hopefully we can get a reasonable, oh, it has, okay. So a little bit better results here where at least we've got something plotting. So it's showing the different driver numbers. So it's just by car number and the maximum deceleration, which is kind of interesting. So the AI BI Genie is kind of interesting in a couple of different ways. First, it's early days, or reasonably early days. I think this has only been around for 18 months. You can really own it and craft it. So I've configured it to use certain tables here, given it some instructions about how to calculate certain things, and I've given it a query here to show, here's how you get the telemetry for the fastest lap. And you can add to this and continuously shape it and form it so it can actually answer questions better by giving it lower level instructions on how to respond to the English queries. So you can see that this would present a big opportunity or really be a big assistance to business users. Databricks launched something or they announced something, they haven't launched it yet, called Databricks One at this year's summit, where Databricks One is just basically going to be a slimmed down version of the UI that you can pass over to business users so that business users can come into an interface like this and start asking questions. You've got monitoring and history, so you can actually see how the Genie space is being used and then make adjustments accordingly. So that's kind of a taste of what's in this platform. This one is very actually hard to demo this, as you've seen, because it's an LLM and I've been manipulating data. And to get it to the point where it'll actually pull out exactly what you want takes a little bit of work. But once you kind of get your data to a point where it's a little easier to for the LLM to understand, you can get some really good results. I've seen some really good demos of this, and you can see that there's a lot of promise there. Okay. Let's talk about architecture. So, like I said, this is cloud. Databricks is cloud agnostic. So Databricks they basically have a piece of the infrastructure that they host. They work very closely with Microsoft, AWS, and Google to plug into the native cloud capabilities on each one of those platforms and integrate with the platforms like quite tightly. It's very well done. So what that means is you own your own infrastructure as much as you want to. So that means the storage, always the storage. I say always, but generally storage is always on your actual storage accounts, stored in an open format. So Databricks uses Delta tables, and it's a format built on top of Parquet. It's all open source. And if you ever said, okay, I don't want to use Databricks anymore, you could always pick up those files and just go somewhere else with them. So if you decided, oh, this is, I want to move between cloud providers, I want to try using this with a different framework, say you want to use DuckDB, or maybe you want to try something like Fabric, you could take your Delta files and they work everywhere because it's an open source platform and there's lots of different ways to plug in and read those Delta tables. So I say the infrastructure is mostly on your infrastructure. You own your storage accounts. That's where the data is kept. You can also choose to own the compute. So that means that When you spin up a cluster that will do the processing, so that's a big advantage of the way Databricks works. It's built on Spark, which separates the storage from the compute. So any processing you do is separate from storage. Traditional databases, they were rolled together. But separating that out allows us to kind of choose different options in how we want to approach that problem. So when you are using your own compute, you will see VMs that Databricks deploys on your behalf into your subscriptions in Azure or your account on AWS. So your own virtual machines and the IaaS layer, which does process the data for you. We do have the option for serverless compute. Databricks has added that over the last couple of years. It's very, very good and allows you to spin up clusters faster and also be just a little bit more effective, efficient at times, depending on what your security requirements are, depending on what kind of work you're doing. Serverless is a good choice for some of those scenarios. Not all of them, but some of them. Again, for networking, it integrates with your cloud platform networking, so you can basically have another layer of security around everything and protect it with all the bells and whistles that you'd expect to have on your native cloud platform components. So on Azure, this means you can have everything running within your virtual networks. You can protect everything with private endpoints, and you can harden everything and lock it down quite tightly. If you are using serverless, you're of course running on Databricks infrastructure, and you can specify the ingress and egress control to really keep a fine grain on what traffic can leave your networks to protect against expropriation. For security, so of course you've got your cloud platform user access control. In addition to that, you've got within the Databricks workspace, there's sets of permissions within there, so you can control who has access to what within the workspace. So that's basically those various menu items. You can say, okay, only certain people have action or permission to do certain things in the workspace. So see those various menu items and do various things within the workspace itself. And then Unity catalog permissions are kind of a separate thing from that. So Unity catalog permissions means that anything you have in the catalog, so Unity catalog, I guess, backing up one step, is a set of features within Databricks for governing data. So that means when you see something like, go back to the Catalog Explorer, basically within catalog here, you've got various ways of storing and exposing your actual data assets. And you can control that using there's a whole security set of security permissions around that you can control who has access to what at a very fine grained level. Okay. Okay, so this is a bit of a peek into the full-blown Azure deployment. So we tend to use the hub and spoke design. This is recommended by all three of the major cloud platform providers. So in Azure, you have really any of these. You can talk about Azure, you can talk about AWS or GCP. You basically have your network connectivity, your network traffic flowing out of a hub, and then you have a data landing zone or another area where your actual workload lives. So we generally deploy the connectivity in one subscription from an Azure perspective. We set up all the components that it needs to communicate. Databricks has this concept of an auth-only workspace where it really allows you to lock down who that's being exposed to and allows you to expose the actual workspace with private endpoints. The data landing zone, the workspace that you'll actually be working on lives there, along with your data lake and your compute if you're using classic compute. From more of a network perspective, this is how it would all fit together. And you can see I've included in here the Databricks control plane tenant. So this is basically where the Databricks UI lives and where the serverless clusters live. So if you're using serverless compute, it lives up here in basically the Databricks tenant or the Databricks account in AWS speak. So this is where Databricks provisions things on your behalf within their own account within their own tenant that you're using. So really, when you're looking at the workspace, this UI here does not live within our infrastructure. It lives on Databricks infrastructure, and we can protect it using private endpoints. And that's really what this is showing to a large degree. Okay, so let's talk about that a little bit in more detail. Going to hit the Azure portal here. All right. So if I go into, let's go up to the DLZ. So this represents the landing zone, which was on that diagram. This is up. So if I go back to the diagram here, we're looking at this piece and really everything that goes with this. We tend to group things into what we like to call data app environments. So within our data app environment, so we've got some supporting infrastructure here. So we've got some network pieces, some NSGs, some route tables, some virtual networks. So this is all Azure. It's just Azure, right? There's nothing special here for Databricks at this point. This is a data app environment. So we've called this Data Boost Dev, and it's in Canada Central. And what we're looking at here is the workspace and some connectors for the workspace so that the workspace can easily integrate with the on-prem, or sorry, not the on-prem, the Azure native components. So this means we've got a way to talk to the Key Vault, and then we've got a way to talk to the storage account here. And you can see these components here. So we've got an Event Hub namespace, we've got a Key Vault, and we have storage accounts. And if I actually look in this storage account, I've given myself enough access. I've got a Formula One. No, I've not given myself enough access. But this is where your data lives. It's within your storage accounts. These are all available to you for you to access. Databricks is not controlling they're not keeping your data locked down so you can't work with it directly. If you need to get data out of your storage accounts, they're just plain storage accounts on Azure or your S3 buckets on AWS, and you can use that data. You can move it around as you see fit. Okay, so that's a quick peek at the architecture and the infrastructure. Let's talk about data management and engineering. This is where teams tend to spend the bulk of their time in Databricks. So basically, at the core of everything is notebooks. And like I said, these are essentially IPython notebooks or Jupyter notebooks. There are other ways of storing this data, but out of the box by default, you're using IPython notebooks. There's orchestration. So like I touched on, there is the concept of jobs and an orchestration engine built into the product. There's DLT and Lakeflow Connect. So the language on this has changed a little bit now. There's Lakeflow Connect, which is the ingestion, and Lakeflow, I think they call them declarative pipelines, which used to be called Delta Live tables, which was kind of not a great name. So I do like the rebrand into Lakeflow and the various areas of Lakeflow. There is the data catalog. There's quality tools built around that. Some of that is provided by something called DQX. That's by Databricks Labs. They have a whole labs arm, which provides all kinds of first-party kind of testbed solutions to some degree. It's kind of hard to describe. Some of this stuff you would want to use, it would be perfectly acceptable to use in production, and some of the things from Databricks Labs are experiments. So it's kind of one of those things where they offer a lot of experiments that you can kind of go through and see if they'll help you or not. DPX is one that we've started looking at. It's their data quality framework, and it's really great. And Lakehouse monitoring is something that's built right into the platform, and I'll show a little bit of that. And then you can have data alerts that basically are queries that run on a regular interval and can send alerts to different endpoints. And I'll show you what that kind of looks like. Okay, time for another demo. Let's look a little closer at notebooks, workflows, catalog, and queries. So I'm going to hop back over to the environment here. And I'm going to go back over to my workspace, and I'm going to go into my FastF1 demo. So this is the notebook I used to ingest data for the demo. I was using a Python package called FastF1. It's a pretty interesting open source platform, or really library, Python library that allows you to easily work with race data. It's quite popular and quite interesting. So you can see here, we can just use a pip command. So this is looking like, if anybody who's familiar with Python, it's quite convenient. You use this magic command, which is the just prefix of a percent sign to specify that you're on pip, and you can run any pip commands from this. So you can bring in any Python libraries that are available on the net, basically. So we bring that in. We then restart Python using another magic command, and then we can start writing code. So I'm going to import FastF1. And like I said, these are Jupyter notebooks, so you can mix in Markdown with your code to really document it inline, which is nice. I really like the way of doing this. And you can see that this heading here forms the table of contents, so it makes it a little easier to navigate. So we imported here, and you can see I was looking for the first qualifying session, and just getting the name of that session just to see this was how I was getting familiar with the API. And getting the dates, loading the session, and then I can look at results. So this session.results actually returns a pandas data frame. Now, when you're working with Spark, pandas data frames are not necessarily native or distributed. So that's kind of suboptimal, but it does display. We can work with it. But as you can see down here, I can create an actual Spark data frame based on the session results, and then display that, and I actually get a richer grid out of that. So there's some flexibility there, which is always nice. And you can see this is just my results table here, so you can see basically the positions in order. So Norris won the first race here. Look down. Yeah, so makes it easy to kind of explore your data as you're going through. The Jupyter Notebooks way of working, right? Where you can write snippets of code, execute them in line, re-execute them, modify them. It makes it really easy to kind of massage the data and work on the data. So we've got some lap data here. And I essentially do some ingestion here. So I've wrote some more complicated code. We've got a method here to save the pandas list to Unity catalog. And this allows me to kind of loop through and grab the data. So I've grabbed the data from, where's my range, 2025 to 2021. So this was the notebook used for that. So you can see there's a lot of flexibility just in itself here. I can write whatever Python code I want to write. So I can use pre-canned libraries. Python is really easy to work with. So you can write as much, like as simple or as complicated of logic in here as is needed to get the job done. And then you can also write inline SQL. So you can see I can change the type of the cell. So this notebook defaults to Python, but I can change it to SQL for the cell, which puts in this another magic command, and then I can just run a simple SQL statement here. So I can get my list of sessions. And down here, just inline, I wrote some. I spent a lot of time working with this data set to get the dates and times in a format that I could actually work with and that the LLM could work with for AI BI Genie. So turns out I could have probably selected a better data set, but it was kind of interesting working through that and getting an understanding for where the limitations are for the AI BI Genie. I don't think anybody else would have as hard of a time. Turns out I picked like about the hardest set I could because manipulating those time spans are quite tricky. Okay, so I've got this Fast F1 demo notebook, and it's building me out essentially a set of tables. So in my output here, or not in my output, but in my catalog, this is the raw data I'm ingesting. So I have laps, I have results, sessions, telemetry, and weather. And then I've built a couple of silver tables. So I've got laps and telemetry here. You can ignore these two for now. So these are the tables that this notebook creates. But of course, I've just been running this ad hoc. Every time I want to refresh the data, I just will run this notebook. And it will bring in any data that I don't have because I've got to check in there to see if there's anything new. But if I wanted to run this on a schedule, all I'd have to do to create a job from here, once I've got some working logic, is hit schedule. And it will bring up a scheduled job that'll run every day on a serverless cluster. So I can click create here. And here's my job. I can click into that. And here it is. And I could even run it now. And we'll see how well this actually works. Now, I wouldn't actually do that with this notebook because that notebook hasn't been like prepped to move between environments. It's got some test data in there. There's a bunch of optimization you can do for your notebooks to make sure that they're going to run efficient and effective and alert you when something goes wrong and things like that. So this is not actually something I would put in production, but this is a good example of just how easy it is to stand up one of these jobs. That's great. I wanted to show how easy it is to do that. Once I brought that data in, now if I want to query against it, you can see it's as easy as writing a query. So I can select here, I'm running against a serverless warehouse, and it's going to query my catalog. So it's going to look at my catalog and bring back those results. I can do all kinds of things from here, right? There's all kinds of great filters built in. And I believe I've done this in a little while, but you can do some exporting. There's all kinds of different things you can do with this, with these data sets, which is great. So that's the basics of some of the data engineering stuff. So it makes it really easy to manipulate your data, to work with your data using the notebook environments, and to schedule those notebooks into jobs once you've got them working the way you want. All right, quick time check, like 15 minutes. DevOps. Okay, let's talk about DevOps a little bit. The platform has a lot of really good observability built in, so it makes it easy from an operations perspective to see what has happened when something goes wrong. So Databricks has really expanded on this. So Unity Catalog, that set of features that was rolled into the product a few years ago, has a really strong set of observability and monitoring features. Actually, let's jump right back into that. I wanted to show another piece on the catalog here. What you can do from the catalog as you're browsing. So let's just talk about the catalog just a little bit more. So you can see, first of all, here, the product will suggest descriptions for a table, which is great. You can attach metadata to this. This is good for both the LLM looking at this, and it's good for users who are trying to find the data that is relevant to them. You can do the same thing with columns. So you can attach comments at both levels. So I can generate a comment here, and here you go. It's pretty good. Revolutions per minute, the engine speed of the vehicle at a specific point in time during a racing event, critical performance indicator. Like, this is a pretty good description for something that I didn't have to type anything for. So that's baked right into the product. You can of course get some sample data. It'll take a quick look at the table here. Got some details on where it's stored, and you can see this is just in my storage account, which is great. Lineage is a great feature. I love this so much. This makes data engineers and analysts' jobs so much better because I can I can look at this graph and get a quick look at, okay, where's this table? What's flowing into this table so I can see the tables that were used to build this one and then what's being built off of it. And did I set up data profiling for this one? Yes. So there's also a set of data quality features. This is around lakehouse monitoring, and you can build dashboards, quality dashboards easily off of your data set. This probably won't show any very much useful data, but it's one click to get this set up if you've got a data set that you've already refined. Okay. So that's a little bit of the lakehouse monitoring features. I want to talk about CI/CD really quickly and Terraform. So let's talk about CI/CD first. So we set up our notebook, and we built a job on the notebook. Click into here, I can look at my job again. So now, how do we package and deploy that and move it around? So what I'm going to do is I'm going to switch to another session here. So over here, I've got just this is my other account. And what I'm going to do is I'm going to grab that notebook and I'm going to add it to what Databricks calls a Databricks Asset Bundle, or DAB, or you'll maybe see it referred to as a bundle or an asset bundle. But it's basically the project system for grabbing any of the assets you need to move between environments. So I've got a special folder here. So this F1 demo folder is actually hooked up to a Git repo, which is very easy to do in the platform as well. So this is already hooked up, and I'm going to go create asset bundle, and we'll call it F1 demo, and it'll be an empty project, and I'm just going to create it. I don't have anything to deploy yet. And it creates me this container, basically, where I can store my create a source folder here, source, and I will create another folder here, and we'll call it resources. And in my source, I'm going to copy my job or my notebook in here, and I'll copy my job definition into resources. So let's go over to source. Actually going to go through this UI. Not. I'm going to go back here and grab this URL. Okay, I'm going to own this. To my source folder. So there's my notebook sitting within my source folder. I'm then going to add we'll just go with this for now. So basically, this has created a bundle with a single file in it for the FastStep1. And from here, I can use the deployment engine to deploy to various environments. Makes it really easy to do that. I can also commit this. And push it. You can see it's an IPython notebook here. I can commit it and push it, and then in VS Code, where we've got a Databricks extension installed, I can grab the latest changes, all integrated with Git, and I can view the notebook here. I can open the project here. And this gives me the ability to work with that bundle right from this environment and deploy it to other environments, validate it, work on it. So I can easily move code between VS Code and the workspace itself. So you've got a lot of flexibility in terms of tooling. As for Terraform, I just want to touch on the Terraform provider. It's very mature and robust. There's very good documentation around it. So if you are working with Databricks, Terraform's probably a great choice because it'll work with any of the three providers that Databricks is set up to work with, the cloud providers. And you can see there's all kinds of overlap between there's a lot of components and things that are specific to each platform, so you can provision your infrastructure to be exactly how you want it and very repeatable, and has all those great infrastructure as code benefits that you've come to expect. Okay. I'm going to skip over ML ops and logging and monitoring and alerting. I'll just take a quick look at our job here. So we ran that job. What you can do here is you can set up job notifications. So on failure, by default, it's sending an email. We can also set up all kinds of different destinations, including a custom webhook. So for example, if I wanted to create a ticket in ServiceNow, or if I wanted to create a ticket in Azure DevOps, I could create a webhook as a relay that sends it to something like an Azure function, shapes the data how I want it, and sends it off to the ultimate destination. But we've got quite a bit of flexibility just built into it. The Teams notification is a really nice thing that most of our clients really enjoy, because they can have a dedicated channel which will show them any job failures. So this is pretty easy to get started. There's pretty good documentation around that, and it works really well. Okay. Moving on over to AI ML, I just want to give a quick tour of some of the features that are built into the platform, because there's really strong functionality around AI and ML built into the platform. So I'm just going to go back to this and collapse this up. I guess I'll give a quick explanation of each one of these first. So AI BI Genie, you've kind of seen, that's a very low code, low configuration way of hooking a large language model up to your existing data that you've brought into your catalog. AutoML is a bit of a framework built into the platform. It's using, under the covers, it's using HyperOpt for hyperparameter tuning and model selection. So it basically scans through models, cycles through parameters, and finds the optimal output. So it's really good for testing if your data set is a good candidate to predict a specific metric and to select a baseline model. MLflow, this is effectively DevOps for ML. It allows you to kind of automate and govern your models and features that you're working with. Mosaic AI is a set of tools to help build, deploy, and evaluate compound AI systems. So if you're doing things like data prep, model fine-tuning and pre-training, and RAG, you get up to tools or like search, doing things like evaluating the output, and then governing and monitoring the full system. Mosaic AI is a set of tools that kind of chain everything together and make it easy to work with that. And then I just want to point out that there's like a really good amount of support for for generative AI in Databricks, and really it'll support almost any LLM. So I just want to touch on, let's talk about that last point. So model serving, you can see here, it's pre-configured to use a bunch of Databricks hosted models. So you've got a bunch of Claude models, you've got some Llama models, GTE models, but you can configure it to use external models as well. So you could use OpenAI. You'd of course need a OpenAI API key, but there's a lot of different models that you can hook up to your hook up within your Databricks environments to use in things like Mosaic AI. I'm going to dive into the playground here because I find this really cool. So what you can do with the playground is you can actually start testing different models. So if I wanted to see how Claude performs with a specific tool versus another model, so say we're going to use Claude and Llama, I can effectively say, ask it various questions. So this is a kind of nice thing where it will run through, basically, as you type in the prompt here, it'll run that prompt against both models, and then it will evaluate the output. So it judges and will also help you form new questions to ask the model. We don't have any tools hooked up, so I'm not actually going to run this, but you've got quite a bit of power using the playground just to explore the capabilities and to wire it up with some of the tools. So as far as tools go, you can hook it up to curl APIs. You can apply it directly against data. You can build functions within Unity Catalog and have it pointed towards that. So there's lots of functionality you can put these models to kind of build your own, to build your own set of tools and your own complex AI system if something like the AI BI Genie isn't quite cutting it for you. Experiments are where you go to start your basically your AutoML to look at, okay, what can I do now? I just basically click through this so we can have something to look at. You can select a, this is classic machine learning. It's basically looking to select a model for you and help you get started. So it builds you out a notebook for your best model. So you can go and look through what it's actually built out for a notebook and explore those results. It does some data analysis and profiling. So you can look at your data exploration notebook, and it'll basically give you some nice stats on what your data looks like. So some data set stats, builds these fun kind of word clouds down here, which is mileage may vary on how useful that is, but being able to explore your data, and I didn't build any of this. This was a run created by AutoML. So I basically ran this, I walked away, I came back, it had built these out, it had tested through, to reduce my zoom again, it had tested through these various models to see how well they performed while trying to solve the problem I gave it. So really interesting set of features available there as well. Okay. Features and models, I'm not going to dive deep into those, but that's basically where your features are your data sets that you're looking to train your models against and evaluate models. So your test data sets, your training data sets, and then your models, of course, are the models that you've selected. And these are actually empty here, so no sense looking at that. Okay, that's a lot of info dumping. I'm going to wrap us up. So basically, Databricks has a lot of bells and whistles. There's a lot of features. It is a very large product that can do a lot for you. Try out out the free version. Go and get your hands on it. It will do quite a bit for you for $0. So you can play with it a lot. I've played with it a fair bit to get a sense of what you can and can't do, and you can do a fair bit. Start with data engineering, of course, getting your data into your catalog and getting things set up in a well-structured, high-quality manner is your first start. Don't ignore architecture and security. So, running with something like the free version or even going into Azure and clicking create workspace will only get you so far. You're basically going to end up with problems if you're not looking at that reasonably early. You'll have issues with cost, with data exfiltration, with a bunch of different things. So pay attention to that. It's not necessary when you're just playing with it, but once you want to actually get it ready for production, make sure you understand what options are available for you and how to lock down the platform. What's your cost? So once you do have an environment up in Azure, just pay attention to cost. There's a lot of built-in tools into Databricks and into Azure or AWS to actually look at what's being spent where, and then be able to rein in some of those costs if they start getting away from you. And always consider your data strategy, data governance, and data quality. These are huge. So if you start trying to build AI without having a solid data strategy, really high quality, really well-governed data sets, you're going to end up in some pain. So I really recommend looking at those things. And lastly, how can we help? So we can work with you for advisory sessions, working with you to define a data and AI strategy. We can help you create a Databricks adoption roadmap. We can work with you to establish and implement all kinds of governance and security policies. We've got experts who are really intimately familiar with rolling out a governance program in your organization and helping manage that change, because it's a big undertaking. And workshops are always a great way to get familiar with things and to start experimenting. So really looking at use cases and then building out POCs and getting some people ramping up in the product is a great starting point. And that's it for me.